Next we are moving to the question number 79. So 79 question is on the screen. So match the Zenon compound in column 1 with its structure in column 2 and assign the correct code. So if you see, there is a lots of Zenon compound they are given, but in examination we no need to solve each of them. Okay. So let us start with the easiest one. So see Xe4. So if we draw the structure of Xe4, we are obtain this. So it is nothing but this is the structure of square planar. Okay. So if you see the options, option A we already known, option A is matched with option 2, but in the first case it is matched with option 1, and if you see the fourth option it is matched with option 3. So option 1 and option 4 we are neglected. Now see, option A is matched with option 2 and option 2 in the two options, that is option 2 and option 3. Now if you see the B having the same, so no need to change it. Now if you see the structure of option C and option D, there is a major difference will take place. So now we move on to see what is the structure of option C and option D. So now if you see the option C and option D, so let us start with option C. So XeO4. So what is the structure? And this structure is nothing but this is the structure of square pyramidal. So option C is matched with option 4. So if you see the option A is matched with option 2. So these two are already neglected and remaining two are we have to left. Now we already know that option C is matched with option number 4. So which one is given? See here option number 4 is given and here option number 1. So this again option 3 is neglected and we are get only option number 2 as the correct answer of this question. So in this way, if you are going to solve, you are save your time, and that time you are utilized to solve other questions which is given on your physics and your biology. So question number 80 is given on your screen. The magnet and the permanganate ions are tetrahedral due to. Now first we have to see what is the manganate and what is the permanganate ion. So MnO4 2 minus is your manganate, and MnO4 minus is your permanganate. Okay. So structure of MnO4 2 minus is Mn double bond O double bond O, O minus, and permanganate Mn double bond O double bond O double bond O, O minus. Now these double bonds are formed by the d pi and p pi bonding. Now see, in the first option the pi bonding involves overlap of p orbitals of oxygen with d orbitals of manganese. So this is the correct answer of these statements. Now if you see there is a no pi bonding, this is completely wrong because we have already got the pi bondings. The pi bonding involves overlap of p orbitals of oxygen with the p orbitals of manganese. That is not the p orbital, it should be a d orbital. So option 3 is also again cancel it out. Now if you see the option number 4, the pi bonding involves overlap of d orbitals of oxygen. Oxygen does not have the d or d orbitals, so option number 4 is cancel it out. So we have only one option, that is option number 1 is the correct answer of question number 80. Next we are move on to the question number 81. So question number 81 is on your screen. So which of the following species is not stable? Now let us move on to the solution. So, carbon family is college students get some problem. So, this is the easiest way to remember the carbon series. Again I am going to repeat, college students get some problem. So, here only we have to focus on this silicon part, okay. Remaining or we are going to delete it. So, silicon. Now, the silicon size is not so big. Now, if you see the options, in options the Cl6 having a very larger size. So, for silicon it is not possible that it can accumulate the 6 Cl minus ions. So, as a result this SiCl6 is not stable, and here they are asking which is not stable, and your correct option is option number 4. So, 4 is the answer of the question number 81. Now, we are move on to the next question, that is question number 82. So, question number 82 is on your screen. So, for a cell involving 1 electron, E naught cell value given as 0.59 volt at 298 Kelvin, the equilibrium constant for the cell reaction is. Now, this question is come from your electrochemistry part from class 12 chapter. Now, move on to the solution part. So, we know one formula, that is it should be E cell is equal to E naught cell minus 0.059 by n and log of q. So, this is the formula which we are going to use to solve this problem. Now, here they are mentioning the equilibrium constant. So, during equilibrium your q value is equal to k E q, and your E cell, not the standard one, that E cell which is not given as a standard condition, that value is also equal to 0. So, now if I am putting this 0 here, and if I am going for remaining equation, E naught cell minus 0.059 by n log of k equilibrium. So, 0 is equal to E naught cell minus 0.059 by n log of k equilibrium. Now, E naught cell is going on that side. So, we have to left it out as 0.059 by n and log of k equilibrium. Now, this n value is 1 in this reaction. So, 0.059 by 1 into log of k equilibrium. Now, in that equation they also given the value of E naught cell. So, how to find out E naught cell? The value is 0.59 is equal to 0.059 log of k equilibrium. Now, log of k equilibrium is equal to 0.59 divided by 0.059. Now, if you solve this one, you are end up with the result as 10. Now, we have to remove this log. So, how it? This k equilibrium is equal to 10 to the power minus 10, sorry, that should be 10 to the power 10, and the value is 1. And if you see, the 1 value is given in all the equations. So, k equilibrium value is coming as 10 to the power 10. So, this one we can write as 1 into 10 to the power 10. So, this is our answer. So, now see the option number 3 is 1 into 10 to the power 10 is the correct answer of this question number 82. So, question number 83 is on the screen. So, which of the following is an amphoteric hydroxide? Now, move on to the solution. Now, if you see, this whole things are nothing but these are your alkaline earth metal. So, in alkaline earth metal, this beryllium hydroxide is basically act as an amphoteric hydroxide. Okay. And this questions is directly taken from your NCERT from class 11 chapter of S block element. So, now we are move on to the next question, question number 84. So, question number 84 is on the screen. A gas at 350 Kelvin and 15 bar has molar volume 20% smaller than that for an ideal gas under the same conditions. The correct actions about the gas and its compatibility factor Z is. Now, we are moving to the solution part. So, if you see in the questions, they already mentioned that your molar volume 20% smaller than that for an ideal gas, means the V real will be smaller than your V ideal. Now, we know the compressibility factor, that is Z is equal to V real by V ideal. Now, if V ideal value, I am changing the color, V ideal value if it will be increases, then definitely the Z value will be decreases. This is a general mathematical form. If the down part value will be increases, this value is automatically decreases. So, Z will be your less than 1. Now, if you see in your options, option number 1 where Z is greater than 1, so this we can neglect it out. Now, if you see the option number 2, Z will be greater than 1, so this one also we can neglect it out. Now, we have left it out only two options, option number 3 and option number 4. Now, in option number 3 Z less than 1, option number 4 also Z less than 1. Now, when Z less than 1 will happen, the attractive force is dominant over the repulsive force. Now, you see the options, in the option 3 it is written as attractive force, where in the option 4 it is written as a repulsive force. So, repulsive force is not dominant. So, we have left out only one option, that is option number 3, and this is the correct answer of the question number 84. Now, we are moving to the next question, that is question number 85. So, question number 85 is on your screen. A compound is formed by cation C and anion A. The anions form hexagonal close packed HCP lattice and the cations occupy the 75% of your octahedral voids. The formula of the compound is. So, now we are moving to the solution part. So, this question is basically come from your solid states chapter of your class 12 NCERT. So, if you see here, the anions, they are basically placed in hexagonal close pack. So, A is present in HCP. So, number of anions are 6. Now, cations are occupied in 75% of your octahedral voids. So, now number of cations is 75%, it means 3 by 4, for octahedral voids it will be 6. Now, if you do 2, 3, so it will be 9 by 2. So, if I am going to write here C, that is 9 by 2, and your A is 6. Now, if I do the cross multiply here, C 9 A 12, again cancel it out by 3 and 4. So, C 3 A 4. So, C 3 A 4 is the correct answer. Now, if you see among your options, option number 3, which is C 3 A 4 is given, and this is the correct answer of your question number 85. So, now we are moving to the next question, that is question number 86. So, question number 86 is on the screen. In which cases change in entropy is negative? So, directly we are move on to the solution part. Now, if you see the first option, that is evaporation of water, it means water is in the liquid form and it is converted into water in vapor form. Now, if you see in the vapor, the entropy will be more if I am compared with liquid. So, delta S here is always be a greater than 0. So, this is not the case of negative entropy. Now, if you see the expansion of a gas, now anything will be expand, then the entropy is automatically will be increases. So, here also the delta S is greater than 0. So, this case is also not the negative case of entropy. Now, sublimation of solid to gas. Now, in sublimation process also delta S is always be a greater than 0. So, this process is also not a negative entropy questions. Now, if you see in this one, fourth one, so if you see here the number of reactant molecule is 1 and here is 2. So, if I am going to find out the delta S, so delta S is nothing but 1 minus 2. So, my answer is coming as minus 1 and minus 1 is less than 0. It means the delta S is less than 0 and this is the correct option of the entropy which having a negative. So, option number 4 is the correct answer of question number 86. So, question number 87 is on the screen. So, which of the following series of transitions is the spectrum of hydrogen atom fall in visible region? So, this question is directly come from your NCERT, that is from the structure of atom which is given on the NCERT 11 first part. So, the option is nothing but this is your Balmer series. So, Balmer series is the correct answer of this question number 87. Now, we are moving to the next question, that is question number 88. So, question number 88 is on the screen. The method used to remove temporary hardness of water is. So, this question is come from your hydrogen chapter which is given on the 11th chemistry. So, if you see the Clark's method, Clark method is basically used to remove the temporary hardness. And remaining this chalcogen, that is used for the permanent hardness. Option number 3 is also used to remove the permanent hardness, and option number 4 it is also used to remove the permanent hardness. So, option number 2 is the correct answer of question number 88. So, now we are moving to the next question, that is question number 89. So, question number 89 is on the screen. So, which one is malachite from the following? So, if you see the options, option number 4 This is the general formula of the malachite, and malachite is nothing but this is the ore of copper, and this question is come from the general principles. Which is given on your NCERT class 12 part. Now, we are moving to the next part, that is the question number 90. So, question number 90 is on the screen. The correct order of the basic strength of methyl substituted amine in aqueous solution is. Now, we are moving to the solution part. So, if you see in the prime amines substance, we are getting 3 amines: primary amines, secondary amine, and our tertiary amines. Now, how primary amines are look? It's having hydrogen here, and 1 alkyl groups. Secondary amine looks like this: 1 nitrogen, 2 alkyl groups. Now, in tertiary amine, it's look 3 alkyl groups are present. Now, if you see, these alkyl groups are nothing but these are the plus I groups, and nitrogen having its own lone pair. And basic strength basically explained by the lone pairs. When these lone pairs are easily available, then that compound or that element is more basic in nature. Now, if you see here, 1 plus I group is there, and plus I group is nothing but they are the electron rich groups, or we can say they are the Ambanis of your organic chemistry. So, what will happen? We have to get the order like this: tertiary will come first, then your secondary, and then your primary. But amines doesn't follow this order. What will follow? It will follow secondary, then your primary, and then the tertiary. So, why it will be happen? Because of the crowding effect. Crowding effect. And who create this crowding? Your R groups are creating this crowd, and due to this crowd, these lone pairs are not easily available. As a result, the basicity of tertiary amine is automatically decreases. So, if you see the option number 1, this is your nothing but this is your secondary, because 2 alkyl groups are there. This is your primary because 1 alkyl group is there, and this is your tertiary. So, this is the correct answer of the question number 90. So, my doctors, today we study lots of concepts regarding chemistry. So, for next class we are going more further details. So, till then keep studying.